Forget a tropical vacation. Picture a planet where lead puddles like water, clouds spew acid, and the air could crush you like a grape. This isn't some dystopian sci-fi, it's Venus, our seemingly Earth-like twin turned into a blazing inferno. Earth chills at 15 degrees Celsius while Venus cranks up the heat to a blistering 462 degrees Celsius, hot enough to boil your blood. How did this Earth cousin become a planet on fire? Join us on a journey to unravel the mysteries of Venus's fiery temper. We'll crack the code of its runaway greenhouse effect, explore its toxic atmosphere, and even dare to ask, could life exist in this hellish oven? Venus isn't just hot, it's a furnace. While Earth basks in the sun's gentle touch, Venus gets full, blistering heat stroke. But why is this seemingly Earth-like twin planet baking under such an infernal spell? The answer lies in a twisted trio of factors: its proximity to the sun, its runaway greenhouse effect, and the unique composition of its atmosphere. Compared to Earth, Venus hangs out a cozy 30 million miles closer to the sun. This might seem like a small difference, but think of it as the difference between lounging by the pool and getting stuck in an oven on broil. Venus receives nearly twice the solar energy Earth does, and that's just the opening act of the heat drama. Imagine Earth's atmosphere like a cozy blanket, warming us just enough. Now, picture Venus wearing a suffocating, heat-hugging quilt. Its dense atmosphere, laced with thick layers of carbon dioxide, acts like a one-way valve for solar energy. Sunlight easily penetrates, heating the surface, but the trapped heat can't escape. It's like cranking up the thermostat in a car with all the windows shut. Temperatures skyrocket. This self-perpetuating cycle, called the runaway greenhouse effect, is the main culprit behind Venus's fiery temper. Earth's atmosphere is a well-balanced mix of gases, with nitrogen playing the starring role and oxygen a crucial supporting actor. Venus, however, throws a wild atmospheric party where carbon dioxide takes center stage. This potent greenhouse gas makes up a staggering 96% of Venus's atmosphere, compared to a measly 0.04% on Earth. It's like replacing the comfy sweater you wear on a hike with a thick fur coat at the beach. You're bound to sweat. Other trace gases like sulfur dioxide and chlorine also contribute to the heat wave, adding their toxic spice to the already scorching brew. These three factors, proximity, greenhouse effect, and atmospheric composition, form a lethal cocktail of heat, transforming Venus from a potentially Earth-like planet into a boiling, sulfuric wasteland. But the story doesn't end there. Stepping onto Venus would be like taking a dip in molten lava disguised as a planet. With temperatures hot enough to melt lead and an atmosphere dense enough to crush you like a soda can, Venus holds the dubious title of the most hellish world in our solar system. Buckle up, because we're about to take a virtual trip to this unforgiving inferno. Imagine landscapes so scorched they blur the line between solid and liquid. Forget rolling hills and babbling brooks. Venus boasts vast plains of solidified lava, volcanic mountains spewing sulfuric fumes, and craters filled with molten rock. The average surface temperature? A blistering 462 degrees Celsius, hot enough to vaporize most metals and even char spacecraft. This constant furnace renders any hope of liquid water, the elixir of life, utterly pointless. Breathe easy, Earthlings, because a single, deep breath on Venus would be your last. Its atmosphere is a suffocating cocktail of gases, with carbon dioxide making up an astonishing 96%. But the real kicker is the sulfuric acid, the same stuff that cleans your drains. Imagine swirling clouds of this corrosive beast raining down on you, melting your suit like a candy bar on a summer day. And if the acid doesn't get you, the pressure will. Venus boasts an atmosphere 90 times denser than Earth's, like being submerged a mile underwater, except it's boiling acid and lead rain instead of refreshing H2O. Earth has a magnetic field, a cosmic shield that deflects harmful solar radiation. Venus? Not so lucky. Its magnetic field is virtually non-existent, leaving it exposed to the sun's full, unfiltered fury. Forget a tan, you'd get third-degree sunburns within seconds. This constant solar bombardment not only contributes to the scorching temperatures but also blasts the planet with high-energy particles, further contributing to its hostile environment. In this unforgiving environment, where even the toughest metals crumble and the very air burns, any dream of human exploration seems like a cruel joke. Yet, Venus whispers intriguing secrets. So, intrepid space explorers, did you pack your heat-resistant suits and acid-proof umbrellas? The journey to Venus's surface awaits, but tread carefully. This is one vacation spot where even the souvenirs melt. Sulfuric clouds, molten plains, and temperatures that would fry an astronaut faster than a sunny-side egg. But amidst this inferno, Could there be any spark of life, even a flicker of possibility for the tenacious microbes we find thriving in the most extreme corners of Earth? Buckle up, because we're diving into the realm of speculation, where science dances with hope in the heart of Venus's fire. While Venus today is a bone-dry desert, geological evidence suggests a different past. Billions of years ago, vast oceans may have graced its surface, creating habitable zones where life could have taken root. The echoes of these ancient seas linger in the form of dried-up riverbeds and canyons, tantalizing whispers of a time when Venus wasn't just hot, but possibly teeming with life. But these oceans vanished, perhaps boiled away by the runaway greenhouse effect, leaving behind a desolate, parched landscape. Even if Venus's surface is a death zone, could its clouds host life? High above the inferno, at around 50 kilometers altitude, temperatures dip to a balmy 30 degrees Celsius. Here, suspended in sulfuric acid droplets, scientists have detected traces of phosphine, a gas often associated with biological processes. Could these be signs of extremophiles, hardy microbes adapted to this bizarre, acidic environment? The jury's still out, but the mere possibility ignites our imagination. This is today's video. Hopefully you find it amazing.